Hi everyone, welcome to Mathematics Parshala. This is Naresh. Today I will discuss this problem which came in CSIR UGC net June 2024 in part B. This question from ordinary differential equation. Let's see the question. Let phi denote the solution to the boundary value problem. Then we have to find what is phi. Let's see the problem. What is given? X y dash whole dash minus 2y dash plus y by x equal to 1. So now we break this derivative. So what we get? Basically we get x y double dash plus y dash minus 2y dash plus y by x equal to 1. So it can be written as x y double dash minus y dash plus y by x equal to 1. So it can be written as x square y double dash minus xy dash plus y equal to x. So now you can see this problem is called homogeneous linear equation or Cauchy-Euler equation. For solving this problem there is a prescription. What is that? We have to put x equal to e to the power z. X equal to e to the power z. It will give z equal to ln x. So z equal to ln x. So dz dx will be what? 1 by x. Now we will transfer the dy dx and dy dx to in z. So what we get? Dy dx equal to dy dz, dz dx, and dz dx equal to 1 by x. So 1 by x dy dz. Okay. So this gives x dy dx equal to dy dz. Now we have to find d2y dx2. d2y dx2, it can be written as ddx of dy dx, and dy dx equal to what? 1 by x dy dz. So ddx of 1 by x dy dz. Okay, so from this we will get minus 1 by x square dy dz plus 1 by x dy dz. Sorry, 1 by x into ddx of dy dz. Now d2y dx2 equal to minus 1 by x square dy dz plus 1 by x. It can be written as d2y dz2 into dz dx. dz dx is 1 by x, so basically we get 1 by x square dy dz plus 1 by x square d2y dz2. Okay, so basically we get d2y dx2 equal to 1 by x square, take common, d2y dz2 minus dy dz. Yes, if I take 1 by x square common, so d2y dz2 minus dy dz. Okay, so from this what we get? X square d2y dx2 equal to d2y dz2 minus dy dz. So the given equation is what? Given equation becomes this x square y double dash minus xy dash plus y equal to x. So x square y double dash minus xy dash plus y equal to x. This becomes what? d2y dz2 d2y dz2 minus dy dz, and xy dash becomes dy dz. So xy dash becomes dy dz, so minus dy dz plus y equal to x. We can x written as e to the power z because we put x equal to e to the power z. So basically the equation becomes d2y dz2 minus 2 dy dz plus y equal to e to the power z. Okay, this equation is very easy to solve. So for this we have to auxiliary equation becomes what? For this auxiliary equation becomes m square minus 2m plus 1 equal to 0. So auxiliary equation becomes m square minus 2m plus 1 equal to 0. Auxiliary equation, so m minus 1 the whole square equal to 0, it gives m equal to 1. So the complementary function becomes of the equal to c1 plus c2z into e to the power z. Now we have to find particular integral. So particular integral will be 1 by d minus 1 whole square e to the power z. Okay, where d equal to d dz. Now what we know that 1 by d minus a to the power n e to the power az will give z to the power n by n factorial into e to the power az. Here a is 1, here you can see here a is 1 and n is 2. So what we get? Z square by 2 factorial into e to the power z. So it gives z square by 2 e to the power z. So the solution will be yx equal to c complementary function plus particular integral. So it will give, what is complementary function? Complementary function is this and particular integral is this. So final solution becomes c1 plus c2z into e to the power z plus z square by 2 into e to the power z. So basically what we get? c1 plus c2z plus z square by 2 into e to the power z. So yx becomes c1 plus c2z plus z square c2z plus z square by 2 into e to the power z. Now we transfer from z to x. What we basically get? Z equal to ln x, because x equal to e to the power z. So put here c1 c2 ln x plus ln x whole square by 2 e to the power z means x. So yx becomes this. Now the boundary condition is what? y1 equal to 0, y to the power 4 equal to 4 e to the power 4. So what is given? That y1 equal to 0 and y e to the power 4 equal to 4 e to the power 4. Now from this what we get? y1 equal to 0 will implies 0 equal to c1 plus c2 ln 1 plus ln 1 whole square by 2 into 1. Now what we know that ln 1 equal to 0. So basically becomes c1 equal to 0. Okay. Now y to the power 4 equal to 4 e to the power 4 will gives what? 4 e to the power 4 equal to c1 becomes 0. So c2 e to the power 4 c2 ln e to the power 4 plus ln e to the power 4 whole square by 2 into e to the power 4. Now what we know that ln e to the power 4 equal to 4 ln e. Ln equal to 1, so becomes 4. So from this what we get, let's check. 4 e to the power 4 c2, that becomes 4. That means c2, that means we can write 4c2, and from this 4 square, ln e to the power 4 becomes 4. So 4 square 16 by 2 plus 16 by 2 means 8. So 4c2 into e to the power 4, e to the power 4 cross off, so it becomes 4 equal to 4c2 plus 8, 4c2 plus 8, because e to the power 4 e to the power 4 cross off. So basically we get 4c2 equal to 4 minus 8 equal to minus 4. So c2 equal to minus 1. So the solution becomes yx equal to c2 becomes minus 1. So let's see, minus ln x plus ln x whole square by 2 into x. This is the final solution, and the final solution is what? Phi x. So phi x equal to yx, so that becomes minus ln x plus ln x to the power whole square, ln x whole square by 2 into x. Now we have to find phi e. So let's check what is phi e. Phi e means minus ln e plus ln e whole square by 2 into e. Now ln e is 1, so minus 1 plus 1 square, 1 square means 1, so minus 1 plus half into e. That means we get minus e by 2. So phi becomes minus e by 2. So the option 1 is true and other option should be false. So the right answer is option 1. Thank you for watching this video. Thank you very much.